In this section, in addition to putting the equations in standard form, we need to determine whether we are dealing with a circle, ellipse, hyperbola, or parabola. In this first equation, the first two terms give our answer away. We have a minus sign between the x squared and the y squared, and that tells us automatically we're dealing with a hyperbola. Now, let's put this into standard form. Let's begin by grouping the x and y terms separately. We begin with 9x squared minus 36x, leave a blank, minus 16y squared minus 64y, leave a blank, equals our constant 172. We will then factor out the leading coefficients. A 9 factors out of the x grouping, giving us x squared minus 4x inside, and a negative 16 factors out of this y grouping, leaving y squared plus 4y inside, close parentheses, equals 172. Be careful when you're factoring out that negative to change the sign inside the parentheses. Now we begin the cut in half and square step. The negative 4 in the x grouping cuts in half to a negative 2, which in turn squares to a 4. That's not really a 4 because there's a 9 out front that distributes to it. It's really 9 times 4, which is 36, that we've added to the left. So we need to add 36 to the right-hand side to balance that equation. Likewise, inside the y grouping, the 4 cuts in half to a 2, which in turn squares to a 4. But that's not a 4. It's really negative 16 times 4. We've really subtracted 64 on the left, so we need to subtract 64 on the right-hand side also. Okay, now we complete the square. The x grouping becomes x minus 2, quantity squared, with a 9 out front, and this is followed by negative 16 times y plus 2, quantity squared, equals 144. That's what we get when we add these values together at the right. Now, we don't want this equal to 144, we want this equal to 1, so we're going to divide by 144 on each side of the equation. This gives us x minus 2, quantity squared, over 16, minus y plus 2, quantity squared, over 9, is equal to 1, and that is our equation of this hyperbola in standard form. Since x squared is listed first, this is going to be one that opens left and right. This next equation begins with a 9x squared plus 25y squared. Since we have the sum of two squares with different leading coefficients, that tells us we are dealing with an ellipse for this problem. So let's now do what we did in the last problem. Grouping the x's together, we just have 9x squared, there's nothing else to go with it, plus 25y squared minus 100y, leave a blank, equals 125. We're only going to complete the square in y for this problem, so I will bring down the 9x squared and factor the 25 out of the y grouping, which will give us a y squared minus 4y inside of the parentheses. And then we will begin the cut in half and square process. In the y grouping, the negative 4 is going to cut in half to a negative 2, which in turn is going to square to a positive 4. But that's not really a 4. There's a 25 that distributes to it. That's really 100 that we've added on the left, so we need to add 100 to the right-hand side of the equation also. Now we can complete the square, bring down the 9x squared, plus 25 times the quantity y minus 2 squared equals 225. We don't want this equal to 225, so we're going to divide on each side of the equation by 225, and it's very convenient that 9 times 25 is 225. So we're going to have x squared over 25 plus y minus 2 quantity squared over 9 equals 1 as the standard form of this ellipse.